Let's look at these 5 graphs. You put that quiz away. They're good scores. Turn to percent, they're good scores. What's that? I just did tests. You keep quizzes and you keep tests. Okay, so quite often, with real world data, so you just did this quiz paper, and that's nice, but this isn't real practical stuff. I doubt there's many of you that, as a profession, when you're all big boys and girls, that are going to sit around and just solve math problems that have no meaning to them, like these.
You do.
I do, but it's a rare profession that you do that. So instead, let's try to move a little bit toward what are some of these topics that we've been talking about, practicing, that had no meaning. Let's try to give them a little bit of meaning. But realistically out there in the world, there's not too many times when your data is negative numbers. Now I can think of temperature, right? And I could think of bank accounts maybe go negative, but there's not a lot. It certainly exists, but not a lot of data that's negative. So what that makes happening is often, this is a graph from another class for something, don't worry about what's up here, but often it means your graph is only important when it's up here in this first quadrant. Because you see your x's go to the right, that makes them positive, and your y's go up, so they're positive. It's unusual to be over here, because those would have negative x's. It's unusual to talk about anything down here, because that would be negative x's and negative y's. And it's unusual to be over here, negative or positive x's, but negative y. So often, all you see of a graph, what's realistic, is just that first quadrant of things. So let's go to number 1. And we're going to go first and make a pass through all 5 of these with you just identifying the name of that shape. So here's somebody that has electronically collected data and graphed it. You're going to graph some stuff by hand in a little bit, but this looks, a nice and professionally graphed. And so they've kind of drawn a trend line or a pattern. And if you're looking at number 1, can you identify what that came from? That's only the first quadrant of stuff. Can you tell what number 1 is a piece of? What name of our shapes? Okay, let me help you. The mind plays tricks on you as to, you know all this, it's going to be real obvious to you in a minute. We have names of things like a parabola. We've talked about hyperbolas. We've talked about things that just make lines. A lot of our parabolas, how's that? Look like that. But if all you're going to see is the first quadrant, then just take away the other 3 quadrants. And that's all you'd see. Okay, let's go talk about this hyperbola. So if k is positive, there's our hyperbola. But if all we see is the first quadrant, that's what you're going to see. Makes it a whole new look, doesn't it? Lines are lines. First quadrant. We had that other one that didn't have a name that did this. Remember this one? Mm-hmm. Do you remember the equation for this one? This was y equals, is it k times or k divided by something? K divided by, is it the x or the x squared? Good, it's the x squared. This was the y equals k divided by x. But on this one, if we take away everything but the first quadrant, so that you don't see the negatives because they don't really pertain to it, now look what you see. It's hard to tell the two apart. If we had a really good graph, one of them actually comes a little bit farther down before it heads out. We don't need to worry about that right now. What's the equation of a parabola? Y equals, is it k times or k divided by? K times what? This is our hyperbola. This would be our other one. It's called an inverse square. So I'm going to write that name just so you don't start calling that a hyperbola. Inverse square. And equation for our line? Y equals kx. Like mx plus b, especially if it's going through the origin. Y equals kx. So back to number one. You had a good idea of parabola, so for number one, label it as a parabola. Number one, call it a parabola. And would you just write that generic equation next to it? Parabola and y equals kx squared. How about number two? What do you think that is? Staring at you. What is that shape?
Parabola.
It's another parabola. The whole thing's there. Now you can see negative x's as well. But that's a parabola. Up there by number two. And so what equation are we going to attach to it?
Y equals kx squared.
That's exactly right. Y equals kx squared. How about number three?
Hyperbola.
Yeah, probably. On my paper I put hyperbola with a question mark because I don't really know if it's the top one or the bottom one up on the chalkboard. So I did write hyperbola next to number three, but I'm not 100% that it's a hyperbola. So it could either be y over kx, it could also be y equals k over x squared, So I put them both down with a question mark next to it.
So if it's y equals k over x squared, then it's not a hyperbola?
That's right. It's not called a hyperbola. The hyperbola is just that top one. That bottom one most people call inverse square, but guess I don't see that 100% of the time written that way. Here's where it gets its name though. Inverse because of the k divided by, square because of the square. But it's the one that has the teeth to it. But if all you see is that first quadrant, how do you know, right? How about four?
Parabola.
Parabola. Sometimes it's hard to tell. Like on four, if it wasn't arched quite that much, sometimes it is hard to tell if it's a line or if it's a parabola. It's hard to tell. You will learn with our graphing calculators when we do more with them. We can have our graphing calculator tell us a little bit better. So your equation would be y equals kx squared. And how about 5? I think that's a line. And so don't forget your equation. Maybe just y equals kx. Now normally right now we would say, just flip it over, we're going to do the other side. But it's just so small, let me trade you a front graph version of that. Seems like a good idea at the time. It's too hard to work with. We tried it last period. It was too hard to grasp this guy. We'll try it this way instead. Everybody got one? Go ahead and answer 1 and 2. They're intended to be multiple choice. You might pick more than one answer.
Here's what you're going to work on this sheet. And then here, I'll give you this. We just kind of went through these. What's the formula for parabola? Okay, this will be, we're only seeing one quarter. there. So you can see the whole thing there. This one is hyperbola, essentially, and then there's square root of that, for that, right? And then parabola, can't see it, but there, and then that's what.
Use that yesterday, didn't you?
Then I just formula.
I got it.
And I can use that to help
Did
you.
that translate?
What?
Did it? Did it translate?
Yeah.
Okay, just check. I don't know, nice cookies.
What was the name?
Cookies.
That was, if he didn't get an
I had an extra bag from
Huh?
yesterday.
I have
What'd you say for number one?
A.
You have to use me. How about number two?
C or D?
Yeah, good answer, C or D. Either one, if you picked them, is the right answer. It's hard to tell. It's hard to tell if it's C or D. Let's go get three done. We'll do three together, and then we'll turn it loose on the back side of that. Number three. The amount of force needed to loosen a certain bolt is related to the length of a wrench as given in the table. What do you know about that? If the wrench is longer, is it easier or harder? Easier. So see how that's inverse? The wrench is longer, less force. Make sense? So anyway, well, we just got answered B, didn't we? We got to graph it first though. Let's put the force numbers along that x-axis. So how high do you got to get?
30.
You got to get to 30. So you're not going to be able to number one by ones, it won't fit. So you experiment a little bit, use pencil, so you can change it. Count by something other than ones so that you can get all the way to 30. Let's make our x-axis go to up to 30. Typically the top row would be like x's. It doesn't have to be that way, it's not wrong if you don't. That's just a little bit more like what everybody else does, so if you're comparing and looking, you're looking at the same picture. Anybody find something that worked well? You don't have to keep going. No. We got somebody over here that counted by 5. It didn't take up a lot of room. And that's spread out. Back here we went every other was 5. And then every other 10, every other 15. So every 2 blocks was 5. And the more you can spread them out, I think the better you'll like your graph.
I did 5.
Like each one was worth 5? Oh, but here's the thing. The top row probably ought to be your x's. So do the same thing, maybe just down there on the bottom. So you probably really ought to have those x's down along the bottom. And looks like every other is 5. That is working out well for those of you that have that. Okay, how high do the y's got to go?
Up to 630.
Up to 630. I don't think I'd count by 1. You're not going to make it. So find something that will work, that kind of spreads it out as much as you can. You just don't want it all cramped up. It's hard to see what's going on. It's hard to graph. We got somebody up here counting 2 blocks is worth 100. I see. That looks like that ought to fit well. Every 2 blocks is worth 100. Once you got something that fits, then just go plot those points. And then try to draw in the graph, the shape that you think fits that. So you'll do something like go over 3 up to 630, over 7 up to 270. You good? We got that. Okay, so we just go over 3, and up to 630, so over 3, all the way down to 630. What do you think we ought to call that pattern? And you got things to help you up on the chalkboard. Which one is that like?
Hyperbola and inverse square.
Yeah, probably either the hyperbola or inverse square, but.
Can I choose just like choosing one?
Sure you can. I guess we better answer question B. Is it direct or inverse? Inverse. And then one of the equations, yes, you can just choose one. It's either y equals k over x or y equals k over x squared. And then for part D, we're not going to do a math problem to answer it. I want you to use your graph and go to where 21 inches would be. Make sure you're on inches. Make sure you're on the right axis. 21 inches. Is those x's or y's?
What?
Y's. So you're not going very far. Go to 21 on the y-axis and come way out there to where you think your graph would finally hit. You're just guessing. You're just wild guessing. So if you went to the 21, a height of 21, come way across. Where do you think you're going to hit for how many pounds? Do you need one, Whitney?
Yeah.
Anybody got a shot in the dark?
What?
As to, what'd you say for D?
Probably like 2, or wait.
So if we were at 21,
90.
so you see where 50 is. Those of you that counted every 2 blocks was 100. Go to 50 and then drop down about half of that. So if you're way down at 21, come way across to see maybe where you think your graph's gonna hit. How many pounds?
No, I'm confused.
Maybe 125? Bruce, what do you say?
Like 100.
100?
Yeah, because because between 50 and 30 is like 100.
Yeah, it's tough. And you remember what this is gonna do. Here, let's just use one of these. Do you remember what this graph does as it keeps on going?
Keeps getting closer to the.
I know, keeps getting there, getting closer. I'm trying not to. It never really does get there. So, but the time that you're at 21, so if this was 100, 21, my goodness, is way down here. I try to go out there to see where it's going to hit. That's tough to tell, isn't it? And so, I don't know, 80, 100, what else did I hear, 120? Probably all those answers are good, reasonable. We will learn how to do a math problem with your graphing calculator that'll actually tell us what that is. For right now, we're just looking at the graph. Okay, let's go to the back side.
Okay.
This time, what do we have? A science class, up at the top. A science class investigated the relationship between horizontal range an object would travel and the initial velocity in which it was shot. The object was shot at a constant angle of 40 degrees to the ground. You don't need to use that, but they're just saying it was the same thing over and over. The class collected the data. Alrighty, velocity. Let's put that along our x-axis. How high do you gotta go?
60.
Make it to 60. So find a way to scale that graph paper so that you can get to 60. Along the x-axis, scale to 60. And then your y's, you've got to get up to 362. Figure out a way to make your paper reach to 362. And then you graph those points, go graph all your data points.